Hello and welcome. Today we're going to take a look at how engineering helps keep an aircraft cabin safe and breathable during flight. Have you ever wondered how we can travel comfortably on an airplane, breathing normally, working on a laptop, watching a movie, or even sleeping, while flying more than 30,000 feet above the ground? The answer is a system most passengers never really notice, but one that is essential for both safety and comfort during flight: cabin pressurization. But before we understand how this system works, we need to answer a simple question. Why does it need to exist in the first place? First, there is one important thing to understand. Not every aircraft needs to be pressurized. Smaller airplanes, especially those used for short flights or operating at lower altitudes, often do not have a pressurization system. And that is because at those altitudes, the air still has enough pressure for people to breathe without major difficulty. But when we talk about larger aircraft, the ones used for medium and long-haul commercial flights, the situation changes completely. These airplanes fly much higher in areas where the air is thinner and the atmospheric pressure is much lower. In that environment, cabin pressurization is no longer just about comfort. It becomes a matter of safety, and that is exactly the scenario we are going to understand now. Maybe you are wondering, why does an airplane need to fly so high? The main answer is efficiency. The higher an airplane flies, the thinner the air becomes. That means there are fewer air molecules around the aircraft, and with less air in front of it, the airplane faces less resistance as it moves forward. That resistance has a name: drag. Think of something simple. Imagine you are standing on the sidewalk, and a bus passes quickly next to you. You feel that sudden rush of wind, almost as if the air is being pushed with force. That happens because the bus is large and not very aerodynamic. As it moves forward, it has to push a large amount of air out of the way. Something similar happens with an airplane, but on a much larger scale and at much higher speeds. Drag is a force that works against motion. It is almost as if the air is constantly trying to slow the aircraft down. Now imagine trying to run with an open parachute strapped to your back. You would need a lot of effort just to keep moving forward. But if the parachute were smaller, running would become easier because there would be less resistance pulling against you. With an airplane, the idea is similar. At higher altitudes, the air is thinner, so there is less resistance. The engines do not need to work as hard to keep the aircraft at cruising speed, and that helps save fuel. That is one of the main reasons why large commercial airplanes usually fly at altitudes of around 33,000 to 39,000 feet. But flying that high creates a serious problem. Up there, atmospheric pressure is much lower than it is down here. And although the air still contains oxygen, it is much less available to our bodies because the pressure is too low. In other words, it is not enough for oxygen to exist in the air. The human body needs enough pressure to be able to absorb that oxygen properly. If a person were directly exposed to the outside environment at 35,000 feet, for example, the effects would be dangerous. Dizziness, mental confusion, loss of coordination, disorientation, and within minutes, loss of consciousness could occur. This condition is known as hypoxia, when the body does not receive enough oxygen to function properly. So the big question arises, how can passengers breathe normally inside an airplane that is flying so high? This is where the pressurization system comes in. On many commercial aircraft, part of the air used in the cabin comes from compressed air taken from the engines. This is known as bleed air because it is bled off from one of the engine's compression stages. But that air doesn't go straight to the passengers. Before it reaches the cabin, it passes through systems that control its temperature, its pressure, and how it is distributed throughout the aircraft. After that, it is sent into the cabin, helping to maintain a breathable and comfortable environment. Even if the airplane is flying at 35,000 feet, the cabin is kept at a much lower altitude, as if the passengers were in a city high up in the mountains. That is why you can spend hours on a flight breathing normally, reading, working, watching movies, or even sleeping without ever needing to wear an oxygen mask. But here's something most people never think about. Pressurizing an airplane isn't just about pumping air into the cabin. Pressurization puts a lot of stress on the aircraft structure. Think of a balloon. When you fill it with air, the pressure inside increases and the balloon stretches. A pressurized airplane goes through something very similar. During high-altitude flight, the pressure inside the cabin is much greater than the air pressure outside. That creates a constant pressure difference between the inside and the outside of the aircraft. That difference pushes the fuselage outward, almost as if the plane is being slightly inflated during the flight. That's why aircraft designed to fly at high altitudes need a structure built to handle that stress over and over again. Materials, rivets, joints, doors, windows, and panels all have to be engineered with extreme care. On top of that, the aircraft goes through pressurization and depressurization cycles on every single flight. Pressurizing during climb and cruise and depressurizing during descent and landing. Over time, these cycles require strict inspections, proper maintenance, and constant structural monitoring. So, pressurization isn't just a comfort system. It directly affects the design, construction, maintenance, and safety of the aircraft. So next time you board a plane, sit back, have a coffee, put on your headphones, or close your eyes to sleep. Remember that there's a sophisticated system working silently all around you. While the aircraft is crossing the sky at thousands of feet, the cabin is being carefully controlled to maintain the right pressure, allowing you to breathe normally in an environment where, on the outside, the human body wouldn't last very long. That's aeronautical engineering, and that's exactly the kind of technology, often invisible to passengers, that we talk about here. If you enjoy this type of content, make sure to subscribe to the channel. Thanks for watching, and we'll see you in the next one.